Okay, so we're looking at exercises 9.3, problem 25. And it's a probability problem, no surprise. And it's 25 is about euchre hands. So you've read the setup here. There's 24 cards. Each suit contains the cards ace, king, queen, jack, 10, and 9. And the event that we're interested here is a hand that holds 4 aces. That's our event. But there are a number of different ways to achieve that event, a number of different scenarios. We don't know, we want to find the number of possible ways to achieve that event. We don't know that yet. It's a question mark. But you can imagine there are a number of distinguishable hands in which they all share the same fact that the hand holds all 4 aces. Okay, and then so that's our subset. The universal set is also called sample space, the sample space when you're dealing with probabilities, and that's simply all euchre hands. It's the set of all euchre hands. And of course we want to know how many items are in that set, the universal set also. Anyway, the basic idea of probability is the probability of an event equals the number of items in E divided by the number of items in S, the sample space. And this is the denominator is the easy one to see almost right away. You're dealt a set of cards, and in card games, generally speaking, it doesn't matter what order the cards are dealt to you. Once you get a hand, you can rearrange them and you no longer are paying attention to the order in which you receive the cards. So when the order doesn't matter, remember that's a combination problem. So when you're dealing with card games, it's almost always going to be a combination problem. And there are 24 cards, and you're selecting 6, or the dealer is selecting 6 for you at random, of course. So it's a 24 choose 6 combination problem. So we know that is going to be 24 factorial over 18 factorial and over 6 factorial. That's just the standard formula for combination. For a combination, 24 choose 6. Okay, so let's keep that in mind. That's our denominator. And let's go to a new page and we'll look at the numerator. Okay, so our starting point on this page is what we just found. And so now let's attack the numerator. And again, think of it this way, similar to the problem that came up in section 9.1, where you want to remember that problem had to do with a regular deck of cards, 52 cards, and you're dealt 13. How often or how many hands are there in which you receive the ace of spades and the king of spades? This is similar to that. And so if I asked you how many different hands are there that contain all 4 aces? Well, the first thing you would do would be take the 4 aces out of the deck and set them in your hand. And now you have 4 out of 6 cards. So in order to complete your hand, you need 2 more cards at random. So this is the first part is obviously non-random. That's the point. But now we're going to give you 2 more cards, or you're going to deal yourself 2 more cards. How many cards are left in the deck? Well, there's 20 left, 24 minus 4, and you're going to choose 2, and again, the order doesn't matter, so it's a combination problem. So the numerator is right there. So in this case, the probability of E is combination 20 choose 2 over combination 24 choose 6.